Density is the mass of a substance per unit volume, or how much it weighs per given volume. Remember that density is an intensive physical property because we can use it for identification. It does not change with amount. The density of water is 1 gram per milliliter. It's always 1 gram per milliliter. Looking at this density column, we have corn oil, water, glycerol, as well as some other items. Which of those is the most dense? If you said glycerol, you are correct, because the most dense objects are always at the bottom, and the least dense object would be corn oil, because it's on the top. We can put the definition into a mathematical equation. Density is equal to mass over volume. The units for density are usually in grams, and volumes usually in milliliters or cubic centimeters. Therefore, density is grams per milliliter or grams per centimeters cubed. The density of an object does not change even if the object is cut into pieces. So the density of a whole kiwi is the same as the density of half of the kiwi. The only density that you have to have memorized is water, which is 1 gram per milliliter. Substances that are less dense than water will float. And substances that are more dense than water or greater than 1 will sink. So the first thing that you need to do is figure out that this is a density problem and write your equation. Figure out what was given. So it says a certain sample has a volume of 35.7 centimeters. Label the 35.7 centimeters cubed as your volume. It weighs 85 grams, so label that your mass. Now, we need to look and see what we're solving for. We're solving for density, so we're not going to rearrange the equation. We're just going to put mass over volume, just like we solved our dimensional knot, and we're going to put our volume on bottom. Notice that the units are there. Make sure that you're putting your units. Since I have 1 on top, 1 on bottom, I divide. I get this in the calculator. Look back at what was given. This has 3 sig figs. This one has 2 sig figs. So your answer should be in 2 sig figs. That's 1, 2. So that 3 is going to round up. So we have 2.4 grams per centimeters cubed. Don't leave off your units. Notice neither unit canceled, so they both come down. If you have an irregular shaped object, you can find the volume of it by volume displacement. So to do this, first you would fill your graduated cylinder about halfway with water. So this is the first thing we do. We fill it about halfway with water. Then we're going to measure how much volume the water is taking up. So it's taking up 200 centimeters cubed. And we say centimeters cubed because this is measuring in centimeters cubed. Then it says weigh your object and record the mass. So my object is that rock, so I'm going to weigh it. It weighs whatever, 30 grams. Then drop the object carefully into the graduated cylinder and read the new volume. So now it's 2, 20, 30, 40. So the new volume is around 260 centimeters cubed. So if you subtract those, that volume is due to the rock because that's all that we added. So our volume must be around 60 centimeters cubed. All right, so in this problem, a liquid fills a graduated cylinder to the 45.6 milliliter mark. The empty graduated cylinder weighs 26.5 grams. And then it's filled with an unknown liquid to the 45.6 milliliter mark. The cylinder and the liquid together weigh 70 grams. What is the density of the unknown liquid? So it's talking density, so density is mass over volume. I'm looking for density, so I just need to know the mass and the volume. My mass, I need the mass of the liquid. The 70 is the cylinder and the liquid, and the 26.5 is the cylinder. So to get just the liquid, I need to subtract those. And since I'm subtracting, I'm going to look at number of decimal places. They both have one decimal place. So I keep the 43.5 grams. Over my volume. The liquid is filling it to 45.6, so that is my volume of my liquid. So I just divide. And I have 3 sig figs. And I have 3 sig figs, so my answer should have 3 sig figs. That's 1, 2, 3. But that 9 rounds that 3 up. So we get 0.954. Don't forget your units. And that should be your final answer. So on this one, they said the density is 19.3 grams per centimeter cubed and want to know the volume of that mass of gold. And I'm going to put a decimal after the 200, so we have 3 sig figs there. So we know this is our density, and this is our mass. So we write our equation and circle what we're looking for. It says, what is the volume? So I'm looking for the volume. This time, since we're not solving for density, we're going to have to rearrange the equation. You need to rearrange the equation before you plug anything in. So multiply both sides by V. But we don't want mass by itself, so we're going to divide by density. And that's our rearranged equation. M over D equals volume. To plug that in, we're going to put our mass on our top. And density needs to go on bottom. So 19.3 grams goes on bottom. And notice there's this slash. This is the slash. So those two things are the same thing. So on the other side of the slash, we should have our centimeters cubed. Because again, this has 2 units, grams per centimeters cubed. If you notice, our grams cancel, leaving us with centimeters cubed. So from our metric conversions, we would divide because we have 1 on top and 1 on bottom. We had 3 sig figs and 3 sig figs, so 1, 2, 3. That 6 rounds it up, giving us 10.4 centimeters cubed. There should be no reason that you're guessing at your units. My grams cancel, leaving me with centimeters cubed. What you're left with, that's what your unit is. Go ahead and pause the video and try this one on your own. Restart when you have an answer. So it says substance A is the most dense. So it should be on the bottom. Then it says substance C is the least dense. So it should be on the top. Substance D will float on substance B. So that's what you should have gotten. So go ahead and pause the video and try this one on your own. Make sure that you rearrange your equation and try plugging it in like we did a minute ago. So they gave us density, they gave us volume, and we're trying to find the weight in grams. So we're looking for the mass. So solving my equation, density is equal to mass times volume. So I'm going to plug my density in, 13.6 grams over milliliters. And then my volume should be multiplied, so it should be on top. So 35.0 milliliters. Notice that milliliters are canceling, and I'm left with grams. Since they're both on top, I should multiply. And you get 476. I wanted 3 sig figs. I have 3 sig figs, so all I need to do is put my unit of grams. So for this one, go ahead and find your volume of your rectangle. Remember that volume is length times width times height. So on this one, since our density equal to mass over volume, our mass is 1,500 grams. And our volume is 3.4 centimeters times 1.2 centimeters times 1.7 centimeters. That gives you 6.936. And we want 2 sig figs, so that's 6.9. But our unit is centimeters times centimeters times centimeters, or centimeters cubed. And since we weren't rearranging, we just have one on top, one on bottom. We have 2 sig figs and 2 sig figs, so it's just 220. Remember, it's not 22 because we need this placeholder 0. None of your units canceled. So we have grams per centimeters cubed. All right, go ahead and pause the video and try this one on your own. Restart when you have an answer. So the only column you needed was the density column. The one that was the most dense, or Q, should be on the bottom. And then water, we know, is a density of 1. Well, that would be the next dense. Then T. Then S. And finally R. Go ahead and pause the video and try this one on your own. Restart when you have an answer. So we're looking for density, so we don't need to rearrange. They gave us our mass, but we have 2 volumes. So our volume is equal to 7 minus 2, giving us 5. We look at decimal places, so we need 5.00 milliliters. And so our mass over our volume gives me 5 grams per milliliter. but we need 3 sig figs. So it should be 5.00 grams per milliliter.